Hi, this is Edward from Enfield Physics Tutor, and today I'm going to look at this rather fantastic problem from the Isaac Physics chaps and chapesses. We can say that this voltage we know is going to be 230. We know that RB is 10 ohms, so it's worth putting in. What must R be in order for the power dissipated in the bulb to be 100 watts? So we want to put 100 watts here as well. Now let's label a few things on this diagram that will help us. So let's call this current I. We'll let the voltage across this first resistor be V2, and we'll let the voltage across the bulb be V1, and the current through the top of the parallel pair we'll call I1, and then the current through the bottom light bulb, or the only light bulb, we'll call I2, like this. Let's see if we can derive some equations that will help us get the value for R. Let's think about voltage first. Well, the voltage from the supply V is going to be equal to V1 plus V2. We also know that the power across a component is equal to the voltage of that component, or across that component I should say, divided by the resistance. And putting in the values for the bulb, that leads us to power in the bulb equals V1 squared, because that's the voltage across the bulb, divided by the resistance of the bulb, which I'm just going to leave as PB for the moment. So that implies therefore that V1 squared is power in the bulb times resistance in the bulb. Now if we substitute that back into our first equation here, that implies that V is going to be equal to PB RB all square rooted, because up here we have V1 squared plus V2. Now we're in a position where we can get an actual value for V2, so let's sub in the figures. 230 equals the square root of 100, that's the power, times 10, that's the resistance, plus V2, which is what we're after. Now if you do that and work to three significant figures, you get 198 volts. That therefore means that we can work out the value for V1 as well. Now carrying forward an accurate version of this, that will leave you with V1 equal to 31.6 volts. You've got to keep your three significant figures here. Let's see if we can derive some simple expressions for the values of the current going through each of the components. And let's start off by thinking about R, the resistance on its own. Well, Ohm's law tells us V equals IR, as I'm sure you know, which implies that current is going to be equal to the voltage divided by R. So therefore, applying that to the first resistor, we can say that the actual value for I equals the voltage across that resistor, V2, divided by the current through that, voltage across that resistor divided by the value of that resistor, which is R. So that's our next expression. So we now have an expression for I1. Well, can we get an expression for I2? Well, yes, we can. Now we know I2 is going to be equal to the voltage across the bulb, because that's where I2 is going, which we know as V1. And we're going to divide that by the resistance of the bulb, which we know as RB. Now we have values for both of those, so we can put in actual values here. That voltage is going to be 31.6. This resistance is 10. Therefore, I2 equals 3.16 amps. So we now have values for I and I2. Let's see if we can get a similar thing for I1. Well, the value of I1 is going to be the voltage across it, which is again 31.6 divided by R. We don't know what the value of R is, of course. That's what we're after. Right, now we have to notice that in our circuit, the value of I is just simply equal to the value of I1 plus I2. So that's just a simple use of Kirchhoff's laws there. So if we know that I equals I1 plus I2, let's add up our three values for the currents down here that we just calculated just now, or we just worked out. Right, why don't we just put in the value for V2 there? We know what that is. V2 is 198 volts, the three significant figures. So we've got a whole pile of values here. Now remembering that I equals I1 plus I2, we can therefore say that 198 over R equals 31.6 over R plus I2, which we have an actual value for, 3.16. Now, if we multiply through by R, we therefore get that 198 equals 31.6 plus 3.16 times R. And now it's just a question of gathering together the numbers, a small bit of algebra, and we get 198 subtract 31.6 all divided by 3.16 equals R, which implies that R equals 52.7. Great question. Hope you found that useful.